Vermont Yankee did stop the leaks in those pipes. They were, I think, fixed and they refueling. And those pipes were in concrete vaults that were underground. And thereby hangs the tale about they lied. Now, I'm going to paraphrase the discussion because I haven't seen it all written out in the zillions of pages, but it's something like the following. Vermont Yankee, Mr. Vermont, do you have any buried piping that contains radioactive fluids? And they said, well, no. But what they should have said was, but we do have underground piping in vaults, in concrete tunnels that people walk through. So the engineers think of buried piping as stuff you put in a trench and throw soil on, and underground piping they're thinking of as something in a vault. So there was a miscommunication. It wasn't a deliberate lie, but that's a problem, and it's been in the press for a long time. The leaks were relatively small. Eventually it got up to 2.5 million picocuries per liter as they kept getting, they drill new test wells and trying to get closer and closer to the source. Remember, it started out at about 20,000. But this is, if it leaked 100 gallons a day for a year, which is something vaguely what it was doing, that would be over the whole year about 0.35 curies, which is not something you'd like to sleep. But it's all spread out. But just for example, just north of here, all the reactors in Canada are heavy water reactors, and by their nature, they make a lot more tritium. They just naturally make 5,000 compared to 0.35. They make about 10,000 times as much tritium as this one leaked, and that's just the way everyone expects it to work. It works fine. There aren't problems. I haven't gone to the website lately, but it's been a pretty, reasonable, factually oriented website. They tell you what's going on. So you can go there, and I'm sure they still have something still there to tell you exactly the situation without spin. Well, there's another problem you've heard about too, and that is that can we decommission the plant? Well, they had a decommissioning fund. It was, those are the numbers. But as you can see, they need more money than is in the fund at the current time. Maybe the October market rally helped that fund. I don't know. Might about up 90%. So when they decommission it, what's going to happen? Well, here's an example. Another Yankee plant, I think the first one, was decommissioned. You can see they've sort of cleared off all the ground and everything. So it's all gone except that row of stuff in the back. What is that? Well, those are, in fact, casks in which the spent fuel from that plant are stored semi-permanently. Just sort of sits there, probably behind a fence. And that's the kind of thing that would happen at Vermont Yankee if they were to decommission it, because there's no place to put the spent fuel now. As a factual matter, no one's talking about decommissioning the plant. They're talking about putting it in safe store because they say, well, we don't have enough money to do it. We'll just shut it down and leave it there in a safe mode. I personally think that in the back of their minds, you could say, gee, that's great. When the price of energy goes way up, they'll say, do you want that plant operating again? So that's, now, there is an outfit called Vermont Public Interest Research Group, which has been trying to say, shut down Vermont Yankee because it's unsafe, and substitute renewables. We can do that in a few years. We can be clean and green in Vermont and get rid of that evil nuclear power plant. But let's take a look at Vermont's energy consumption in 2008. It was 5,000, I have to use these numbers, gigawatt hours in that year. So that's the amount of money of energy that has to be replaced. Now they're saying, okay, They said, what is the energy program in Vermont?
Efficiency Vermont.
Yeah, efficiency. They say efficiency Vermont has been so effective that we have avoided and the use of electricity, and we've decreased consumption 2.5%. That might be true in the programs that Efficiency Vermont worked on, but in reality, in that year, the power consumption of the state of Vermont went up. So that particular line item in their report about how to get to replace Vermont Yankee doesn't work. Wind. They say, well, we get so much power by wind, and I multiply it out, and then I use that famous capacity factor of somewhere around 0.3 to say, that means to get the 15% or so that energy Vermont needs from wind turbines requires 268 of these enormous machines up and running in the hilltops and mountains of Vermont. Those are not easy to build, they're not easy to site. And those are the biggest and baddest you could get. Next thing you need, according to them, is biomass. Well, the only biomass around here is forests. And if you want to get 938 gigawatt hours per year, figure out how much wood you need. Well, we can grow sustainably a forest that generates about a half a cord per acre per year. If you take out just about, on the average, the forest will grow at about that rate, so you can have a sustainable forest. And the way you do that is you cut down the trees and burn them, and then grow new ones, and every 20 years or so, harvest that crop in a continuous scheme. That would take an area twice the size of the Green Mountain National Forest to supply that amount of energy that the Vermont Public Interest Research Group recommends. Solar. Well, they want 880 from solar power at the cost of PV panels. That's $7 billion. I think it was half of Lake Champlain. Hydro, they're saying we can get 351 gigawatt hours more of hydro in Vermont, but the Vermont Department of Natural Resources says 66. There just aren't the sites available to do that. Methane. Okay. Cow power is the program that's called. Remember, that's also the program that didn't get any bids in the auction because it's tough on the farmer. They can't afford to put a lot of stuff in. They would take more cows than people just to generate that little bit of methane. So, now don't forget about clouds for a minute. Clouds are important because if they shade the PV panels, well, they stop generating electricity. So you have to have something that you can turn on quickly to counteract that. Now, people say, well, we'll just pull it off the grid. And they have the idea in mind that the grid is some vast reservoir of water or something. And maybe they're thinking a little bit like the natural gas system that generates power, in that we have tanks that go up and down a little bit. You can increase the pressure of the gas a little more in the line. So there is a little bit of resiliency in the natural gas supply. There's none in the electric system. There's no inertia. There's no storage. Nothing.